Alright, yes, it's hanging out on Air's Live. Sweet. Okay, hey guys, it's John here. This is going to be the live session number 2. And today we're going to be creating a 2.5D platformer from scratch, and we're going to incorporate a bunch of different puzzle elements, physics-based character controller, and trying to, create something unique. I'm here today with my buddy Sam, who's going to help me out with just verification for your tweets and Facebook posts so we can enter you into the raffle for some free games. And then he's also going to be helping me answer some of the questions you guys have while we're working. Sam, feel free to say hi.
Hey everyone.
All right, so what I'm going to do, guys, I'm just going to go ahead and start a brand new project here for you. Oh, don't look at that. Give me 1 second here. Let me just move all this. Okay. And let me see here. All right, so what we're going to be doing here, I'm going to skip this version, is creating a 2.5D platformer. And basically what we're going to do first is we're just going to design a basic level that's going to give us some of the elements that I want to create. So what I'm going to do is I'm just going to go ahead and start simple with the floor here. If I can get my cursor. Okay. All right, we're going to go and rename this to ground. And what do you think? Should we do wall jumping, Sam? I think we're going to have wall jumping. So I'm going to create something for that. So this will be the ground, or this will be, yeah, we're just going to ground. And we'll have another platform, maybe over here. Maybe then this will be like a moving platform here. And then yeah, we'll rename this one to moving platform. And then here, once you get to this side, this is where we'll do our wall jumping to get up onto something. And then we'll also do some trigger events and have some animations going. Those are always fun to do. Look who joined. Cowan Heedley Wolf. All right, so here we go. We're going to go ahead and create the walls here. And then we'll decide on the type of character controller that we're going to create. So for the first wall, I'm just going to go and do this. Actually, go up and put it right there. All right, so the whole point of this wall is that there's going to be a platform, guys, up here, and basically you're going to have to wall jump to get up to this platform. Sound good? So let's go and do this, and then we'll get inside. We'll do some code in a minute. And hold on, I just want to fix this. Okay. And then here we'll have a, we need to have a second wall jump off of. So we're going to go and do this, put that about right there. If I have to adjust it, I'll adjust it later. All right, so we got 2 walls to wall jump, and then that's going to allow us to get onto this platform here. Okay, so from that point, I'll go ahead and design more of the level at that time. So what I'm going to do here is I'm going to go ahead and start creating a character controller. And I said I would talk about on the Facebook page, there's 2 types of controllers. We can do a physics-based character controller using a rigid body, or we can use one by creating one ourselves using a character controller. There's some downsides to both. For instance, one, unless you're really doing a lot of physics-based interactions, it might be better to use a rigid body. You might get an actual more lifelike experience with a rigid body. But also, if you do it with a character controller, you can create all the physics you want and use the physics you're going to, you can create the physics as you develop. Like, you don't need to use everything the rigid body has. Rigid body can be seen as kind of expensive, whereas the character controller, it allows you to create your own physics. You have to create your own gravity and stuff like that. In the programming session Livestream 1, we did a character controller. The reason why I think I'm going to use a rigid body on this one is because it's going to be useful to be able to control the velocity when you're wall jumping. Because when you jump on a wall, you need to be able to change your velocity to the opposite of the force that you applied to that wall. So if I go, if I'm jumping on the wall to the right, I need to be able to kick off and go to the left. If you do that with a character controller, you have to actually program in that angle calculation from scratch because there's nothing to calculate it. You have to use the on-controller collider hit to do it. So I think I'm going to go ahead and use a rigid body controller for this one and go ahead and create a nice working, physics simulated one. So first thing we're going to do here, I'm just going to go and create an empty object here to organize everything, name it level. I'm going to put all this in it. All right, got a level there. And then what we're going to do, okay, is he joking? When will the podcast start? Will there be popcorn?
No, there will not be popcorn.
Okay. Let's see here. Oh, here, let me add a directional light. Alrighty. And we'll put the light off to about 100. Okay, let's go and create our character. So I'm going to go and create a capsule here, and we're going to rename it to player. I'm going to go and position that over here, and wow, it's way too big. So what I'm going to do is we're going to scale this guy down, and actually real quickly zero this out. Sure the depths are all the same. Oh, they're not. All right, 1 second, guys. I gotta make sure all these depths are on the same level. Okay, there we go. All right, and then we got our level here. We got our player. And here we're actually going to have the camera move with our player anyway, so I'm going to just parent that. All right, so here we go. So we got our platform here and our character set up, and now we just got to go ahead and code in his mechanics. The first thing I have to do is I'm going to be making use of the rigid body. So I'm going to go ahead and add a rigid body controller or a rigid component. And we do want to use gravity, so if I run the game, he's just going to go ahead and fall, and he's going to miss his collider completely. And why? So on 0. And he is at -7. Okay, there we go. Alright, so now we just have to code in his movement. So the controls for this game are basically going to be you have A and D, and then you'll be able to use the space key to move. Alright, the easiest way to get your user input is through the horizontal axes. So I'm going to go and create a new C# script here. Attach it to my player. Alright, and what I'm going to do here is I'm just going to go ahead and cache the rigid body. Performance it uses. So we're just going to say my rigid body. Huh. Hey Sam, can you hear me?
Yep.
Okay, yeah, okay, just making sure. Google Hangouts just said I was like muted. Alright, so we have my rigid body equals this dot rigid body, and that's going to be our rigid body component to the game that the script is on. Alright. So now that we've done this, what I'm going to do here is you're supposed to use the fix update when you work with rigid bodies, but I think because of how I'm doing the input for movement, I'm going to use update just because I think it might cause a little bit of a lag. I'm not entirely sure, but I'm just more comfortable doing it this way. So I'm going to go and say float H for horizontal axis. I'm just going to assign that to the input. This is just how we get, this is mapped to the this is mapped to the AD keys. All right, and basically what I do here now is I'm just going to use velocity to move our character. So velocity, guys, is just direction with speed. So I should probably give myself a speed variable. So I'm going to go ahead and say here, what's a public float speed. So to get the velocity, I just got to say my rigid body. And you'll see that a property comes up saying that you can get this value or you can set the value. And it's a vector3 type. So I'm going to go ahead and say equals a new user input on the x-axis, which is h. And then that's going to be multiplied by the speed. Right? And then for y, the velocity is going to be basically whatever for the y-axis. It's going to be whatever the velocity on the y currently is. The reason why I don't want to do 0 is because if I do 0, I won't be able to fall off. See what happens. So if I run this, I can move like this. Gravity isn't really taking place. That's because my velocity.y is being constantly set to 0. To fix that, what I can do is I can actually just say here, I can say my rigid body dot velocity dot y. If I go ahead and run it now, you'll see that I'll fall naturally, and it can. Oh my God, what just happened? Okay, so the reason why that's happening is my restraints, because I'm using a capsule collider. I need to freeze my z rotation and my x rotation, and we should be good. Yeah. All right, so we got our character moving. And now what we can do now is we can go and jump, and we'll go and create the logic for if we're grounded. There's two ways we can go about that. We can check if we're grounded, I guess, through like raycasting, or we could check if we're grounded through using like on collision exit or on collision enter and stuff like that. Sam, what would your opinion be on which would be better?
On collision enter.
Okay, you think on collision enter over casting a ray continuously?
Yeah.
Okay, so we're gonna go ahead and do the.
Wait. You can use a physics overlap sphere.
On the character controller.
Yeah. No, on the rigid body to
Oh,
check they're grounded.
Okay.
I would say ray would be easier though.
You think so? If I did a ray?
Yeah.
All right. So, well, you know, I think I did ray casting in my YouTube series. So I'm gonna go ahead and do. Let's go ahead and give on collision exit a try, and we'll see what happens with that. And then if that doesn't work, we'll just do the ray, because I think the ray might be even more efficient to use. First thing I'm going to do, guys, is I'm actually going to tag the ground. All the grounds, like anything that's a game object of ground, I'm actually going to give it a tag of ground. All right, and I'm going to do the same thing for the wall out of L layer time. So I'm just going to go and say here, ground. I'm going to select all the grounds. And some guy says, "You're cool." I think he's talking to Sam.
He's talking to me.
Yeah, probably. All right, we're going to give this a tag of ground, okay? Now, here we go. So we have here, just lost my train of thought. Okay, so what we're going to do now is we're going to go ahead and check if we're grounded so I can jump. All right, so I need a bool. I'm going to do this through a bool system. This bool is going to be true or false if I'm grounded or not. I'm going to go ahead and make it private because it doesn't really need to be public. I'm going to go ahead and say private bool and then is grounded. Default, it's going to be false. And what I can do here in update is I can say basically if is grounded, and you can leave it like this, or you can actually say is equal to true. If grounded is true, then what do I want to do? I want to jump. So I'm going to go ahead and say my rigid body dot velocity equals a new vector 3. Velocity and the x the same. I don't want to touch it. So I'm going to say my rigid body dot velocity dot x. Y. I'm just going to go ahead and say 5.0f. Let's see what happens. And then 0 for z. All right, so grounded is jump. All right, and if I run this, I'll be able to jump regardless. Actually, I won't unless I turn the bool true. So let me go ahead and just create that logic. We're going to use, to test this out, we're going to use on collision, enter, and exit. Someone asked if they could join the Hangout to help answer questions. I think Samuel has it from there, so thank you. And I'm going to go ahead and select some of these. Samuel, feel free to select some of these to answer them. Like, count them as answered, I guess. Alrighty, let's see here. So, okay, so we're going to use on collision enter. So we're going to say on collision enter, void the rigid body physics system. So we're going to say void on collision, well, not unit, from the, or it requires a parameter from the collision class. And basically, is the object that our player hit. The object our player hit is stored in other. So what I'm going to do in on collision enter is I'm going to check the hit is the ground. So I'm going to check the tag. So if other ground, and that means we touch the ground. So I'm going to go ahead and say is grounded. Likewise with the other one, I leave a collider, and I use the same thing, collision, and then other. So whenever I leave the collider I'm stepping on, this function will get called automatically. So I'm going to go and also check the tag that it was for the ground, so that the object I left was the ground. So if other.tag collider.tag equals, I'm going to say is grounded equals false. And actually, I don't think it will right away, because our okay, we're jumping continuously, and that's because we need something to control our bool. We need to control the bool when we hit space. You can see here it's constantly going true and untrue, and we have it in update always checking. So what I'm going to do here is I'm just going to go ahead and say if I hit check if I'm grounded. So if input dot get key down, and then I can do key code dot space. So if I hit the space key, I'm going to go ahead and just say all of this. So if I hit the space key, we're going to check if I'm true, then my velocity on the y goes up. If I'm not, then gravity would take place. Let's go and test this out.
Kelton, for your question, I don't think we'll be doing any modeling. I mean, this is mainly programming.
What about questions regarding things Sam or you are knowledgeable? Wait, what about questions regarding things Sam or you are knowledgeable about?
I think he means we're not.
Oh, okay. Yeah, no, don't worry. We're not doing anything that we don't know what we're talking about. So you're good. Okay, so here we go. We can jump, and I'm actually going to fix our camera here. I don't know what got screwed up with that. So we're going to fix this to Z, 0, 0, -10. There we go. All right, so now I can move. All right, this actually worked really well. I'm happy with this. And I can actually jump up here. It doesn't look like our jump, and I can't double jump. So if I wanted to create that, maybe I will. I can't get up here, though, which is a problem. So I'm actually just going to go and increase that variable. And I put 5 here. Technically, I shouldn't really hard code this. I'm actually going to create a variable for it. And I'm going to go ahead and just say here, public. And here, replace this 5 with jump. Awesome. Okay, so let's go ahead and test that out. See if I can get up there. I'm moving around. All right. So you'll notice that it might give us too much force. The way we can actually fix that is we can edit some of the properties on our rigid body here. And what we're going to do here is maybe give our character a little bit more mass, possibly. Nope. Let me see. Does mass actually do anything for us in this example? No. Let me see. We have here. Okay, so the mass actually isn't taking effect. So 1 second. If I hit the space key, my body velocity equals 3. We go to jump height. All right, you know what? I'm just gonna make it like 8. Let's see. Okay, I'm still not happy with that. Sam, any ideas on why the gravity would be going a little slower like that?
No idea.
All right, let's figure it
Try
out.
changing angular drag to 0.
To what?
0.
0. I think I need a 1, actually. All right, let's try angular drag to 1. I might be doing something. Not really sure. me see. We have constraints on that. Position, jump height is 8. Let me see. He's facepalming. Yeah, facepalm. Give me 1 second. Let's figure out why that's happening, because I don't like that behavior. If grounded, let's see. If input took a key, rigid velocity. Do you think it would be better to add force other than use velocity? To change
Yeah, add force would be much better.
Okay, so we're going to go ahead and say rigid bar dot add force, and it's asking us for a vector 3 force. Let's go ahead and try that. Add force, and we'll say vector time. See what happens here. I think add force takes account of mass and stuff like that. Yeah, force equals mass times acceleration. So I can't actually need more, way higher than an 8 on a jump height, I think. So it's going to make it like 500 for testing. There we go. All right, so that's a more realistic behavior. So I'm going to go ahead and say maybe 150. It definitely works better with add force. It's more lifelike, I think. So in order to jump, we need 250 newtons. And if you're interested in knowing, 1 newton is like equivalent to a doorbell press. If you don't learn anything from this tutorial, at least you learned, or from this video, you learned that. Let me see. So we're going to do like 300, I think. Let's try that. All right, yeah, we're good with 300. Maybe 325. All right, I'm happy with that. All right, so we're going to use add force for 330 here. All right, so now we have a working character controller. I'm happy with this. And what I can do now is I'm going to go ahead and just go through my script here and just clean it up a bit. So it's never a good idea to have your update method necessarily cluttered like this. So I'm going to go ahead and just, I'm going to go down here. We're going to create some functions. I'm just going to take everything that's an update, put it in movement. I'm going to delete it out of update. I'm just going to call the movement. All right, so let's go ahead and let's see what's next in our platformer here. So if I'm running along here, all right, so here we have this huge gap. All right. So I could create a sprint functionality for this. Maybe that's what we'll do after you wall jump. But for this one, I'm actually going to turn this into a moving platform. So what we're going to do for a moving platform, and I've covered it a little bit, actually I covered it quite a bit in my 2D series on YouTube, but what we're going to do here is for this platform, there's a few things you have to figure out, like how can we do this. Let's click on a moving platform. The behavior that we want for it is to start at, for instance, say 29 on the X. We'll say, yeah, 29 on the X, okay, and we want it to just travel like this to 21. Or 20 on the X, 21. So it's going to travel between 21 and 29 on the X. Right? So it needs to go in its fluent motion here. In order to do that, it needs to be aware, whatever script we create for this, it needs to be aware of the position that this is going to be placed in. All right? So these are game objects, which can be thought of as transforms. So what I'm going to do is I'm going to go ahead and actually create, and actually you can do them as positions, actually. And you know what? That might be a better way to do it. I didn't mean to make that a prefab. I'm going to use position variables in my script to tell this object where to go. And give me 1 second here. Hey, Sam,
can use cosine.
Yeah, no, we're not using cosine. Let me see here. Hey, Sam, I have a question. Do you know how to get rid of this thing when it's red?
I have no idea.
Yeah, I've never experienced how to get rid of that. I don't want to like recreate. I think it's because the prefab connection's broken. But I don't want it to be a prefab anymore. So I'm going to delete. And then it goes red. Alright, whatever. Oh, I bet I can hear it. Hold on, I should be able to reset the object. Nope. Alright, we're going to have a red moving platform. It's fine. Alright, so basically what we need to do is we need a script that's going to say you need to travel to these destinations. That script needs to know what these destinations are. So what I can do is I'm going to create a new C# script here. I'm going to do some folder organization. I'm going to say scripts, fire in there. All right, I'm going to create a new C# script, and we're going to name it moving platform. I'm going to go and put it on the moving platform game object. All right, let's go and open that up. So in order for this to work, part of the things that we need are the origin position of the platform and the destination position. The script needs to know where does this moving platform need to go. So what I can do is I can say public vector, and we can say origin. You can say origin, and then I can say here public. So what I can do now is in the inspector here, I'm going to go ahead and just take the 29 here, and I'm going to make it, I guess we'll keep it at negative 7.99. But you'll see here, the origin is going to be 29, the y is negative 7.99, and for z, it's going to be 0. Then for the destination, it's going to be 21, and then negative 7.99 on the y, 0 for z. All right, so now the script knows where it needs to travel to. The next part of this would be like how, what gets it moving. And that's where we have a function called move towards, which can continuously move something with like a speed, with a speed variable. And the way that works is you have to grab the current position of the object and you need to tell it to move. All right, so it's pretty simple. So for instance, if I were to say something like transform dot position, that gets the current position, and I'm going to go ahead and say equals vector. Right, and this is going to be vector 3 current position, a target position, and a max distance delta, which can be almost like the speed of the platform. So for this, I'm going to go ahead and create a variable here, public float. Everyone calls it step. Not really sure why. I'm just going to call it speed. Say the current position is the transform.position. And just because I'm using transform here, I'm also going to go ahead and cache it. So I'm going to say private transform. And then my transform. All right, and I can come down here, change it all. All right, so we're going to go ahead and say my transform, all right, which is the moving platform. So I'm getting the moving platform's position, and then the destination. All right, so the target is going to be the destination position. And then this. You'll see in the scene view that it's going to move. All right, you'll see that, but it's not going to go back. Now, the reason why it's not going to go back is because we never told it to. How does it know when it's time to go back? So what we can do is we can create checks. So destination position, so I can check the current position to see if it's compared to the destination. So I can say, welcome Elias. We can say basically if the my transform.position of the current, if the current position of the platform is equal to the destination position, then it's time to switch. You need to go back. So what we're going to say is we're going to go ahead and say my transform.position equals vector 3.move towards. All right, and what we're going to do here is I need to change some properties. My vector transform.position is destination, and then the destination where we want to go, the new target is going to be the origin, so that it goes back. All right, and then likewise, we can have an else if here for the same thing. And if it equals the origin, then where does it need to go? It needs to go back to the destination. So we can go ahead and say that. So we have my transform.position equals vector 3.move towards, and we need to go from the current position back to the destination. All right, now I already know from experience of doing something like this in the past that this actually isn't going to work right away. If you can see it in the podcast, it moves a little. It's not working now, but if you look at the property value of this, the origin is 29, the destination is 21. But if you look at the value here, it's 28.94. It moved literally a teeny bit and then stopped. And the reason that's happening is because we're technically telling it to do that. Notice that this line of code here, which actually is controlling the movement of the platform, is only called if the destination is equal to our current position, or the origin is equal to our current position. Once you move a teeny bit, this is a false condition. So what we need is a system to be able to switch between, to where this can run continuously until it reaches the destination. The easiest way to do that is through a bool. So I can go ahead here, I'm going to create a bool for switching. So I'm going to go ahead and say here, private bool is switching. All right, what I would say here is, I would say if switching, then I want to go to the origin. Or I guess technically it would be true. If switching is true, I want to go to the origin, right? And if switching is false, if switching equals false, I want to go to the destination. All right, now just by doing this, it's not going to do anything because we haven't told it to make use of these bools. So what we're going to do here is we're actually going to go ahead and create this is going to be responsible for actually moving the platform, but now we need to still check when to switch the destinations and origin, like the new target direction. So I'm going to use another if statement for that. So I'm going to compare. I'm going to say if my transform dot position equal to the origin, then we're going to go ahead and say switching. So if we're at the origin, then switching equals false. Right? Because when it's false, we go back to the destination. All right, we're going to do the exact same thing. And I can do an else if here. And there's probably a better way you can do this, actually. I just realized if I made a variable called destination, I can easily just change that destination, or target. I can easily just change the target variable and use that. But easier for me this way. So we're going with it. All right, so we got our origin here, else if. So we got transformation equals destination. All right, and if it's at the destination, switching equals true because it needs to go back to the origin. Now if I go ahead and test this, it's going to work just perfect. And we have an error. My transform missing an underscore. So I test it out. And you'll see here in our scene view that the moving platform is working perfectly. All right, if I go up to it, go and jump on it, all right, you'll notice there's a problem here. I don't move with it. For instance, if I were to stay still right now, it's just going to fall off. All right. The reason why that's happening is because we need to. We're not parented to it. Like there's nothing saying we need to move with it. The easiest way to move with it is to parent ourselves to it. So what we can do is we can try using on collision enter again and checking for this. Although in my experience, I had a better. I think it's better actually if we just add a second collider and do a trigger check on the platform for it. And we can use on trigger enter and on trigger exit to parent and unparent us. So that's what I'm going to do here. On the moving platform, we need a few things. First off, I'm going to add a second box collider. And yeah, this is completely legal to do. And I'm going to go ahead and raise it up a bit. What I'm going to do here is I'm going to change the center to be just up a teeny bit. And you can see it here that I'm doing that. And this is where I'm going to check for my triggers. So is trigger needs to be checked. Also, in order for this to work, I need... I actually don't know if I need a rigid body since my character is a rigid body, so I might be okay with that one. In order for trigger events to happen, at least one object has to have a rigid body. All right, so what we're going to do here, how do I debug something from Dominic? Be more specific, and Sam will try and help you out. Okay, so what we're going to do here, Alright, yeah, we need to parent ourselves to this using on trigger enter and on trigger exit to unparent us. So in this moving platform, alright, we're going to check for that. So I'm going to have a function here, void on. Alright, we're going to use the collision class, but the collider. We're not working with physics here. We're just checking for a triggered event. Alright, and I'm going to say other again. And basically, other is the object that collides with the platform. So I'm coding right now the platform script, so I need to pretend almost like I am the platform. So what collides with me, which I'm the platform, is stored in other. So what I'm going to do here is I'm going to go ahead and we're just going to basically go ahead and say, we're checking to see if it's the player. I'm going to go ahead and say here if other other.tag equals player, then if other.tag equals player, oh yeah, okay, we need to grab that parent. I need to grab the parent of the player, which is an other. So I need to say other.transform.parent.
Dominic, for debugging, you can use debug.log or print.
Oh, is that what he was referring to?
I hope not.
Okay, well, we're good. All right, so transform.parent equals this return. So now if I run this, I need to add a player tag to my player here. All right, I should get parented to the platform, and I should move with it. So let's go and test it out. I'm going to run over here, get on the moving platform. And you'll see I'm moving with it. All right, I don't have to move with it, I move automatically. Now here's a problem though, watch this. I'm going to go ahead and jump off it, and I'm still going to move with it. It's going to actually pull me back. The reason why that's happening is because we have to unparent ourselves. So we're going to use onTriggerExit to do that. So we're going to copy this, exact same thing, but using onTriggerExit and unparenting. We're going to say onTriggerExit, and then we're going to get the parent, and instead of assigning it to an object, we're going to assign it to null. When a parent to null, it means that it doesn't exist. Let's that out. Alrighty. And there we go. So I move with it, and I can jump off it just fine. Alright. Now, here's the thing about the wall jumping. Watch what happens when we actually go up to this wall. That's an issue here. A bit of research in the past on this. The reason why this happens, guys, is because I'm using velocity, and as long as I'm holding down the right arrow key, the velocity is adding friction and force into this wall, which is going to keep me from falling. Right? So what I need to do is I need to use a physics material to basically say don't include a lot of friction. I just need to set the friction to 0. So what I'm going to do here is I'm going to go and create a folder for physics materials. I'm going to go and create a new physics material. I'm going to name it walls. So we're going to go over here, physics material, and we're going to name it wall. And we have a few properties over here. So the dynamic friction is pretty much what it is. It's dynamic, so if it's moving, if you're moving along something. So I'm just going to go ahead and set that to 0 for now, and then static friction, static, it's not moving, so 0 as well. And what I'm going to do here is I'm going to take this wall material, I'm going to put it on my wall game objects. I'm just going to drag it on there, and then you'll see here in the box collider, it has a material of wall. And now when I go ahead and run towards it, all right, let's go over here. Oh my gosh. Oh wow, okay. So check this out. We have a problem here. I can't jump off the platform. Right, so we need to actually make it so I can jump off this platform. So we need to check code. This is a moving platform here, so I'm just going to go ahead and name it tag of moving platform, or we'll say platform. And I'm also going to create the wall tag. So the platform needs the platform tag, and the walls will need the wall tag. Alrighty. So what we're going to do now is we need to, let's see here. We need to make it so I can actually jump off that platform. All right, that's going to be in our movement. All right, and also, guys, the best part about this is when you know what's being affected, when you program in like an object-oriented manner, I only need to worry about this function here. I know this is what handles my jumping, so I don't have to dig through code finding where it is. I know it has to deal with movement, so I can just come down here and find it. And it's right here when I hit space. So if I hit space, actually it's the on-collision enter part where we're checking grounded is true. So I'm saying here if the collider on the tag equals ground, and then I also want to check for platform. So I would say or other.collider.tag jump off the platform. It's going to bring a whole new bug. Check this out. Just if I jump on the platform, I can also need to include on the for the platform that I am grounded. All right, so we're going to go ahead and we may need to actually do some class inheritance to do that. On collision enter for the player. Oh no, I can do it right here. Yeah, ground, or if it's a tag of platform. So I'll do it right here. Alrighty. Alright, so if we test this out, we should be good to go. Alright, if I jump on the platform, can't jump, and I get parented again, or I get grounded again. Alright, I can jump off it now. Alright, so now let's check out our physics material for the walls. Now you'll notice I can actually still, touch them, which actually shouldn't be happening. Sure. Wait one sec. Let's find out that's happening. Our walls have the physics material. Yeah. The friction is 0. I wonder if our player needs this as well.
Yeah, it's gotta be on the.
Yeah, it has to be on the rigid body controller.
Yeah.
Okay, so let's go ahead and try that. Oh, okay, there you go. Check it out. So now if I run into the wall, I slide right down it. All right, that's what we want. So it needs to be on the. If you're using a rigid body, you have to also have it on there. I think for a character controller, you just need it on the walls. All right, so there we go. So now we can go ahead and start our wall jumping. And because of the way I'm actually controlling the movement using velocity, and the jumping is based on the direction that you're choosing, the wall jumping as of right now actually would work right as is. And you can actually see this. Oh. Remove the grounded stuff, it would actually work perfect, but that's different. Okay, so we need to make it so that we can wall jump. In order to do that, it needs to know that when I collide with this wall, it's okay for me to jump off it. All right. In order to do this, what we need to do is we're going to need a wall script that's going to detect it. So we're going to go ahead and create a new C# script here. We're going to create a wall. All right, we're going to attach it to both the walls. Alrighty, let's see here. Alright, so first thing I want to do is I need to know when the player collides with me. So I'm going to use on collision enter. And what I'm going to do here is I'm going to go ahead and say void on collision enter, and then collision other on collision exit, because we're going to check when you bounce off the walls. Right, from this script needs to talk with the player script, so we are going to use class inheritance here because we need to turn the is grounded bool basically on and off to determine when we can jump, when it's okay for us to jump. So if we collide with the wall, what we're going to do here, and actually, can I do this entirely through the player class? I probably could, right? I have on collision enter and exit. I could just do it right here probably. So I might not even need this wall script. Let's go ahead and try this. So I'm going to basically just go ahead and say or other. Yeah, basically. We have here or other tag equals wall. I'm going to add this exact same thing down there. And this may or may not work. Let's go ahead and try it. All right, let's see here. Other tag is wall, grounded is false. All right, let's go and see. Got an error. All right. All right, so we just wall jumped. All right, now we add a lot of forts going today, I believe. Yeah. Add forts and but however, for the most part, I don't think, or it's also could be from the friction. So actually, you know what? Maybe if we add some friction to the walls, let's try that. Let's go and add like 0.2 or 0.1, 0.1. Try that. And then we're gonna go and do collectibles, and we're gonna go and display parts and stuff like that. There we go. All right, we wall jumped our way up here. And eventually what I'm going to do here is this is going to be, I think we'll do, maybe we can do a sprint, or we can make this like some animation drawbridge. I think that's what we would do. We'll do a drawbridge animation. In order for this drawbridge to work, you need to collect, let's say you have to collect like 3 coins, like that. All right, so what we're going to do here is I'm going to go back over here. We're going to go and create that. And actually, we're going to do a lives and a coin system. So to do this, I need to get some images. So what I'm going to do real quickly is I'm going to go ahead and go to Google. I'm just going to get some health images. I'm going to do that. It's going to get any of them. All right, this blue one seems really cool, so I'm going to go and get this. And we're going to download, save image downloads. All right. And then, where is it? Here we go. I'm going to go and create a folder here for images or textures.
Oh, I can't believe this. I have images, but you don't want them.
Wait, what?
I have textures.
Oh, yeah? For what?
For hearts and what else do you need?
A good coin one. Here, well, I said this one. Yeah, you can just feel free to get me a link on Google. Here, we're going to go ahead and, in order for what we're going to do here is I'm going to use the old GUI system to create and display these icons on the screen as an inventory. For the new GUI system, I'd rather just focus on something related to that in a separate tutorial rather than going through it and you guys, not understanding it. So what I'm going to do here is in order to use this texture on the screen, it has to be a editor GUI and legacy GUI. Right? It's going to be on the screen. It needs to be that type. And I'm going to go ahead and change it down here to about 64 by 64. All right, so that makes it transparent, and now I can actually use it. I'm going to go ahead and rename it to heart. All right, in order to actually see this heart in the screen, what I'm going to do here is I'm going to create a game object, and I'm going to go and create a quad. A quad is just 4 triangles. And what I can do with that quad, as you'll see here, it's just a little square surface. I'm going to go ahead and place the heart on it, and it's going to take the image type of the heart. All right, and you'll notice that it's not just a heart. It's actually it's not transparent in the background. And to fix that, we have to change the shader to transparent diffuse. So I'm just going to go down here to transparent diffuse, and now it's transparent. Okay. And this is going to be our heart. Now, this uses here a mesh collider. Mesh colliders aren't really that reliable. So what I'm going to do is I'm just going to hit convex, and it's going to actually turn it into a more square-like, more a collider that is actually, detectable, more reliable. All right, so this is going to be our heart here. Basically, we're going to have health. We'll start off with 3 health, and you can collect health icons. And we'll say you can get a health icon. If you go all the way up here, you get a health. All right, and then we'll collect 3 coins on the way. What we're going to do here is I'm going to go and create the health system, and I'm going to create that inside the player since it's his health. I'll also do that for the coins. So I'm going to go up here. I'm going to say public int. All right, and we'll say you get 3 lives. Okay. 4 triangles. So what we're gonna do is I want to display these lives for however many I have, whether I have 1 or if I have 1,000 of them. I want to display it on the top of the screen. If you ever played Zelda, this done before in the past. And that's what I want. I want it displayed in the top left-hand corner. The way I'm going to do this is I'm going to go ahead and create a GUI manager script. Right, and this GUI manager is going to be on our main camera. I'm going to rename the quad to heart. Make the heart a prefab folder. We're going to place a bunch of hearts. All right, and then what I'm going to do here is I want to display how many hearts I have. So right in the script, I have 3 hearts, but it needs to actually visualize that. So what I'm going to do here in my GUI manager is I need to know what image to display for how many hearts I have. So I'm going to go ahead and say public texture, and then, oops, mistake. Save the changes to document GUI manager, don't save. All right, here we go. So I'm going to go ahead and say public texture, and then say heart icon. In camera, I can add my heart icon right down here. All right, that's what I'm going to do. Textures, heart. All right, now that I have the heart icon there, what I can do is go ahead and create logic to display it for however many I have. In order to do that, I need access to how many I have, which is in the player class. So I'm going to go ahead and create a private to my player. Handle the player. I'm going to go ahead and assign it to the component. So I need to find that object. So I'm going to say GameObject.find. I'm going to grab the player component. Access to the lives that we have. So what I'm going to do here is I'm going to use void. And inside here, I'm going to use a for loop. And the reason why is because I need to iterate how many lives I have. For every life that I have, I need to display a texture. So I'm going to go ahead and say for lives I have, which is player. All right. Now, what I'm going to do here is I need to go ahead and say here, I need to display it. So I'm going to say GUI.drawTexture, and I'm going to say rect position. I'm going to go ahead and say, first one will be, I'll explain how I do this in a minute, but GUI.drawTexture, I'm going to say 0 from the left, 10 down from the Y. The width is going to be the heart icon. Height is going to be the height of the icon. So heart and the image display. If I ran this, what's going to happen is they're all going to be stacked in the same X position, right, which is here. I need them to be spaced out in the X. So what I'm going to do is I'm going to say 0 times 64, which is the width and size of the icons. And what that's going to do is I'm actually going to say I times 64. So the first life is I, which is 0 times 64, which is 0. The next one is 1. 1 times 64 is 64. It's going to give it an even spacing. So if I go ahead and save this, test it out. Let's go ahead and test it out, and you'll see here I have 3 hearts. Now it's a little too big, so I'm actually going to go ahead, change the texture size down to 32 by 32. And then I'm also going to come in here and do the same, 32. All right, there we go. We got our hearts. So now what I need to do is I need to make it so I can actually collect a heart and add to that. All right, and the way we do that is I simply just create a, I'm not going to delete this wall script. I just create a heart script. And it's just like creating a collectible using onTriggerEnter. So I'm going to go ahead and say heart. And we're going to add it to our heart prefab. All right, hit apply. And what I'm going to do here is we're just going to go ahead and check for onTriggerEnter between this and the player. I'm going to say void onTriggerEnter. onTriggerEnter. I'm going to say collider other. And then what we're going to do here is collider other, and then what we're going to do here is I just need to change the value of their player lives. I need to give them a life. So what I'm going to do here is I'm going to say other, and then I should create a variable for it. So I need to get a handle to them. So I'm going to go ahead and say here if other is player first. So if other.tag equals life. So I'm going to go ahead and say here, I can do it right here. Get components and player. I can go ahead and say here, underscore incremented by 1. So after incrementing it, I want to destroy the heart, so I'm going to say and it should also update on our display here. Alright, so I can't collect it, and the reason being is because it's not a trigger. So if I make it a trigger, now I can collect it and I get 4 hearts. Alrighty, so now that we have that done, let's make that a trigger. Let's go ahead and do the coin, and then I'll go ahead and create a drawbridge. The coin is the exact same thing as the heart. So I'm going to go ahead and just real quickly go to Google and get a coin here. And, coin icon. Alright, so we got our coin here. Open image and image times. I'm going to rename it to coin. I rename that to coin here. Make it a GUI texture so that's transparent. Change the size down to 32 by 32. And then we should be good for this. And actually, you know what? It still has a white background. We need to change it on the material itself. Let's go ahead and create a quad. All right, we're going to rename this to coin. Make it a prefab. All right, we're going to put the coin on the coin. If I zoom in here, all right, let's see if we can get it transparent diffused. Okay, no, we don't get a transparent diffuse. All right, so this is probably a JPEG image, not a PNG transparent. So instead, because I don't want to waste time, what I'm going to do is I'm actually just going to use the heart. In order to activate the drawbridge, you need 4 hearts, and then we'll say, yeah, that will be like a trigger zone. You get 4 hearts, and then the drawbridge will activate. So let's go ahead and actually create the drawbridge. We're going to head on over here to the heart. All right, and our drawbridge is basically going to act where you'll have a ground object like this. I'm going to go over here. I'm going to name it drawbridge. All right, basically what's going to happen with the drawbridge is it is going to act as a drawbridge. So what we're going to do is we're going to have it up like this. Oops. And we're going to have it up. So we'll have it up at 90 degrees. In order to activate it, you got to collect that 4th heart. And when you collect that 4th heart, you're going to need to activate this drawbridge using the mechanism animation system. All right, so it's going to go from 90 to 0 very nicely. All right, so let's go ahead and create an animation for this. What I'm going to do, click the drawbridge, go to the animation view, record a new clip, and name it drawbridge. All right, I'm going to go ahead and for the starting frame, it's going to just go ahead and be here. You can start at 0, it's fine. And then what I'm going to do is we're going to make it this 90. All right, so 90 for the starting. And then what we're going to do is I'm going to go ahead and click on the 30-second mark here. I'm going to change it back to 0. And what we should see now is if I play it, right, you'll see we get that nice drawbridge effect. So it starts here and it drops down to here.
I think it's too fast.
Oh yeah, so we can slow down the sample rate then. So make it like 12. That work?
Yeah, that's perfect.
All right, so we're going to go ahead and save that animation. And what I'm going to do, I'm just going to clean it up. Create a new folder here for animations. Animations. All right, let's see here. Okay, so in order for this to work now, if you click on our drawbridge, you'll see that I have an animator component. Apply root motion doesn't really matter in this scenario. We have a drawbridge here, and what I need to do now is I actually need to change it. If I run this, the drawbridge is going to automatically activate. I need to change the state of this to not be default. So I'm just going to go and create an empty state. And I'm going to set that to the default. And what I'm going to do here is I need to create a trigger. When that trigger is activated, the drawbridge will come down. So we're going to say, right? And the transition from new state to drawbridge is simply when that trigger happens. Alrighty, so we're done here with Mechanism. Now we can go ahead and script this. So what I'm going to do here is I'm actually going to activate everything from the heart script. From the heart script, we can do all the Mechanism stuff. And actually, you know what? I'm going to do it separately on the drawbridge. I'll give them its own script. So we'll go and create a drawbridge. I'm going to attach it to the drawbridge. And what we need to do now is we need to grab hold of our Mechanism animation. So I'm going to go and create a private variable to create a handle to it. And I'm going to come down here. I can have a function here that I can call, actually. I can do it this way. Let's turn the drawbridge into, I can make a static function. We'll do that. I don't know if that's really recommended, but we can do that. We're going to say public static void, and static means it runs along all classes. So I'm going to say public static void, it's going to trigger the animation. So I'm going to say dot set trigger. And we're done. I call that function is immediately before destroying it. I'm just going to go ahead and say drawbridge. Alright, let's go ahead and test this out. Let's see, an object reference is required to access non-static member. Okay, it doesn't like that. What's it all like? Oh, it can't be in a static function. Interesting. Okay, so we're going to do it the proper way. We need access to the drawbridge. So in heart here, we're going to create another handle. And we're going to name it drawbridge, dv. All right, and for killing this object, we're going to go ahead and say here underscore drawbridge. Go and test this out. And I'm going to put this heart like right here. All right, so if we run over here, all right, and this podcast has been going, or this on-air thing's been going for like an hour now, Sam. So it's not as active, but
How many are on?
what? We've got 6 viewers. Oh, we just got 6. But we're an hour in, so I'm just going to bring up again that we're giving away free Steam games. All you have to do to register for it to get randomly selected is you need to you can find the rules on the Facebook page for DGI, facebook.com/Digital Gaming Institute, or you go to digitalgaminginstitute.com and click the links. You can post a shout out using hashtag DGI at DGI students, or you can share the post on Facebook, and you can find more information on the Facebook page. So what we're gonna do here is I'm about to test this. If we collect the heart, it's gonna activate the drawbridge. All right, but now we have a problem here where it's playing looping, so I just gotta tell it not to loop. All right, and the way we can do that is really simple. I'm just gonna go ahead and say here, click on these walls. All right, for it not to loop, I'm just going to change the loop settings. So I'm going to click on the drawbridge animation, just turn off loop time, and that should fix that. Head on over here. And we're going to jump our way up.
You suck.
Okay. And there it goes. Now, it's giving us that abrupt start, and I think that's because the starting frame is 0. So I need to change that. In the animation here, just going to hit record. Whoops. No. Oh, weird. Am I not able to actually edit that? Oh, no, I can. Here we go. It thinks, yeah, the starting frame is at 0. I'm going to make the starting frame at, oh, actually, no, it is. Sam, you have any ideas? Do you see how it does the, like, a really abrupt start?
Yeah, you can just delete the first frame.
Oh, okay, you can. Let me see. Hold on.
Or, instead of having it start...
Can I just delete this key? No, I still need that key.
Yeah, put the key back.
Okay.
Stop recording.
Yeah.
Set the rotation Z to be 90.
At the start?
No, just regular.
Oh, that's why. Okay, yeah. By default, that object's not 90.
Yep.
Okay, I gotcha. Thank you. There we go, and that will give it a more smooth rotation. I was wondering, like, why is it snapping like that?
Did you get the coins in?
I downloaded a non-PNG image. So do the hearts. I don't need to worry about the coins. So if you get 4 hearts, you can activate the drawbridge. Yeah. Alright, there we go. And we can go across now. Alright. What other puzzle elements can we incorporate here? Got any ideas? Or if anyone wants to see an into like on the spot puzzle, let me, if you have an idea, let me hear it. Otherwise, I can look through this, what we have already. We have wall jumping, we have moving platforms, we have collectibles, we have triggered events. What else would you typically see, Sam, in the platformer? I would create enemies, I guess, like Mario style. Do something like that. So what we'll do is we'll go ahead, we'll do enemies. What I'm going to do here for an enemy is just going to be a red cube that moves back and forth on the platform. That's going to basically be in your way of getting. It's going to be in your way of getting the heart. And in order to, if you get hit by it, it's going to take a life. But if you stomp on it, like from the head, you can kill it. So that's what we're going to do. On this heart here, I'm going to set it here at the end. There's going to be a red enemy here. That's just going to be a cube. He's going to try and stop you. So we're going to go ahead and say cube here. All right, and he's going to move back and forth on this.
You can just use the moving platform gun.
Yeah, exactly. That's what we're going to do.
Wow.
So I'm just going to change his material here. Here. So let's say enemy AI script. And I'm just going to go ahead and copy everything in the moving platform here. Except for this stuff. Just going to copy this, the update function, and the variables, I guess. Not really. No, yeah, okay. We'll copy everything up to the update function. We'll pass it. Alright, so what we're going to do here in the enemy AI is we need to make it move. I'm going to use the same code as the platform to do so. So we're going to go ahead and paste here. Alright, just like a moving platform, our enemy has an origin position, a destination position, a speed of 3. We can make that maybe like 2. We have its transform cache. We need to know if he's switching. Everything else here should be good. And if I run this, it's going to actually set up a few things on him. Click the cube here, and this is going to be our enemy. Of enemy. Right, we'll name it enemy, and then what we can do is we need a few things on him. For starters, what was I going to say? Okay, we need the enemy AI script. We need to set his origin. So currently with his origin is, say, 50, 51, 52. Let's say 52. All right, so he's going to go from 52. So 52 on the X, 4.62 on the Y. And he's going to travel all the way over here. He's going to travel all the way over here. And we'll say, what is that? It's 46.02. 46. And then 4.62 on the Y as well. All right, so if we go ahead and run this, you'll see in the scene view, he's moving back and forth. And we have to stomp on him. Now what I'm going to do is, if he collides with us, he's going to damage us. All right, so what we're going to do here is, in our enemy AI, we're going to use on collision enter. So here we're going to have void on collision enter. Actually, I can directly in the player class. I'm going to keep it here though. I'm going to say void on collision enter. I'm going to use the collision. And we're going to go and say here if, here we have if other dot if the player collides with the enemy, then what we need to do is we need to damage him. In order to do that, I need to get access to the player. So our enemy player is. Fine. And what we're going to do here is we're just going to damage him. So we're going to go and say if on collision enter, we're going to say player. That's going to go ahead and damage him. It should. And then what we need to do now is we need to make it where when I jump on him, he gets damaged. If I jump on him now, it's still going to register as an on collision enter. So I'm still going to get hit even if I jump on his head. The trick around that is that we're going to check for. And you'll see him. So what I'm going to do is we're going to give him a little hat, basically. So you have your enemy here, right?
Wait.
Just like
Jonathan, what you can do is check if the player position is greater than the player position Y is greater than the enemy Y.
Oh, on the collision. Oh yeah, I guess you could do that.
Yeah.
When on collision enter is called.
Yeah.
Okay, here we can try it that way. Because what I was gonna do, I was gonna give it like a little hat collider and just check for on trigger enter on that specific hat.
That would require a new script.
No, I think you can do it in the enemy. No, you'd be able to do it in the enemy AI. But no, I like your way of doing that. So let's go ahead and try that. Okay, so we're gonna have here our enemy here. We're gonna compare his Y to the player's Y when on collision enter is called.
If you want to get the exact top, you can just add the enemy position Y. Oh no, never mind.
All right, so we have on collision enter here. So if the object if the player collides with it, instead of just taking damage, we can first check to see if the Y position is better. So if its position other dot my Y. So I can actually go ahead and say here, I can say my transform dot position dot Y. And that means we're above it, right? So if other.chessing.position.y is greater than my position.y, then we're going to go ahead and say destroy this object. Destroy this game object. We can award the player a life or something if we wanted to, or drop a life if we wanted to. Maybe we'll do that. And I think we'll do that. We'll spawn a life or something. And what we're going to say here, destroy this game object. Else, we need to function. Let's go and test that out, see how it works. If it doesn't work right, we may still have to do the other way. On here, real quickly, actually, I'm going to go and just create a material here. Material, enemy. Alright, I'm going to make it red. Alright, put that on the enemy. Alrighty. And then also, let's go and shrink him down a bit. We're going to say 0.6, 0.6, 0.6. Alright. Here we need to change this to Y, actually. Okay, so 4.26. Alright, here we go. So and see. Our enemy's there. Go across here. Jump up here. And that worked. There you go. So we can jump on this. Right.
What you want to do is add force once you hit the.
Oh, once you hit them, so you pop up.
Yep.
Okay, yeah, we can do that. Okay, so enemy AI. So you want to add force to the other objects, right?
Yep.
So you're going to grab the other's rigid body. So other.rigidbody.add force. We're going to say vector3.up. And 1 should be enough. Well, actually, no. You know what? I think we need like a huge power variable when working with force. Don't you?
Yeah, maybe 300 would be good.
Yeah, let's try that. And actually, hold on, I'm just gonna scoot our player over here. Okay, yeah, there you go. So we get the Mario bounce. That's pretty cool. All right, and then we can collect this, and bam. Alrighty. All right, so Sam, it's about almost midnight. For those that tuned in, I think we had like a max of 6. Not as good as my 2:30 a.m. one, but it's all good. What I'm gonna do is, for those who tweeted in Facebook, Facebook shared and tweeted. We're gonna go ahead and put your names into the random selector, and you'll receive a message from me asking for an email. And you'll go ahead and receive a gift to some Steam codes. I'm giving out Steam codes all throughout the week, so you can keep doing this all the way till February, up to February 23rd. On February 23rd, there's going to be no more Steam codes, so you can continue doing it just for a week or for the next 5 days. And I'll be giving them out throughout, and I might even post codes on Twitter and Facebook, and it's first come first serve for those. But other than that, Sam, thanks for helping out with me today, and that is it. Thanks, guys. Hope you enjoyed it.
All right, see you guys.